Cool. Thanks everyone for coming along. As Mel said, my name is James and I'm a principal developer on Jira Software. And the team I'm on specifically builds features around integrations between Jira and developer tools like Bitbucket, GitHub, Bamboo, things like that. So if you've used Jira and you've seen commits, branches, and pull requests show up on your issue, that's the team I'm on. And for the last couple of years, we've been going down a microservice decomposition path. And what this means is that we've built and consumed a lot of REST APIs over the last few years. And in this session, I'm going to be going through some of the lessons that we've learned on how to build better APIs faster and with more confidence using a spec-first development approach. So before I get started, I just want to clarify a couple of things. In this session, I'm going to be focusing primarily on REST APIs. But the mindset, the principles, the way of thinking can be equally applied to gRPC, GraphQL, even Java APIs if you like. Obviously, the tooling is going to be different and your dev loop is probably going to look a little bit different, but the principles remain the same. And when I talk about API specifications, I'm mainly referring to Swagger or OpenAPI specifications. For those that aren't familiar with them, they're a really simple JSON or YAML description of a REST API. A little bit of history, Swagger was originally developed by a company called SmartBear. It gained some popularity in the industry, reached version 2, became essentially the de facto standard for specifying REST APIs. And then about 12 or 18 months ago, it was released as version 3 under the OpenAPI initiative. So I'm going to use the terms Swagger and OpenAPI interchangeably. They essentially mean the same thing. And if there's one thing that I really want you all to walk away from this session thinking, it's think API first. Consider your API a first-class citizen of your development process, not a side effect of your implementation. Because it's the APIs that are the things that we're going to have to support for a long time going forward. So it's really valuable to think about them as a first-class citizen. So I'm just going to set the scene with a bit of a scenario that we're going to work through. Imagine you're in a room with your PM, and they say, we need this super awesome new feature built. And you're like, OK, that's fine. I'm a developer. I get paid to do this. And then they say, it needs a new REST API. We need people to be able to send us data, and we need to be able to get data out. OK. I'm sure most of us in this room have probably built a REST API at some point in our careers. It's not such a big deal. And we've already got some internal and external teams lined up, ready to go. We've got a UI team that's going to be building this kick-ass new feature on our site. We've got a Connect app team that's going to be extending the Jira app to add some new functionality. And we've got an external vendor who's lined up, ready to send us some data that we're going to use in our app. It's going to be awesome. OK, stress level maybe just increased a little bit, right? We've got coordination across multiple teams, possibly some external vendors, and all of the complication that that brings. Oh, and by the way, we're targeting Summit in 6 weeks. We've got marketing lined up. It's going to be awesome. Yeah, right. So maybe stress level has just peaked a little bit. On top of all the other complications, we now have tight deadlines, which are really hard to move. So this just increases the load on our development process. Now, this may seem slightly exaggerated, and possibly it is, but it's actually not too far from what can happen. So the team I'm on was in a similar situation a couple of years ago. We were building a new API which would let vendors and third-party developers send data to Jira. And then we were going to expose that data in a new UI element on the issue screen in Jira. And we were working in a domain that we weren't totally familiar with. It was a fairly new domain, and the vendors we were working with had different domain models, so we had to come up with an API that could work across those different models and provide some value to Jira customers. And we were targeting Summit, so we had quite tight deadlines. So this is maybe slightly exaggerated, but it's not too far from what can actually happen. So let's walk through this in an implementation-first approach, which is what I'm guessing a lot of you in this room are probably doing today. So when I say implementation first, what I mean is that your implementation is the source of truth for your API, and everything else falls out of that. So if you have a Swagger spec, it's being generated from your implementation. And any changes that you make to your API have to go through your implementation first before they can be reflected in your spec. And your consumers are likely building against your real running API. And in this world, this is what defines your API. It's probably spread across multiple files. You've probably got annotations. Maybe there's some XML thrown in there for good measure. It's a little bit messy, right? So let's walk through this. Let's build an app. So maybe you start off with some initial API design work in Confluence. So you fire up Confluence, you sketch out your API, you send it to your team, they comment on it, you iterate a little bit. And this is great. We're being collaborative, we're getting feedback from our team, and we know that collaboration helps increase the quality of what we're building. But what you've just built is a text file, and it's really hard to use that text file in any meaningful way in your dev process, and your consumers can't really use it in theirs. And to be honest, Confluence is not a great format for writing API specs. Are you going to use tables, maybe code blocks? Can't put comments in code blocks. Maybe you're going to have a nested series of indentation or something like that. The point is there's no real standard way of doing this, and the chances are pretty good that your team is going to do it slightly differently to another team, and you're probably going to do it slightly differently between projects. And what this means is that when you send your API out to get feedback, not only does the person have to understand what your API is doing, but first of all, they have to understand what you're trying to tell them and what format you're giving it to them in. OK, so we've sketched out our API. We've had some feedback. We think we're ready to go. Time to write some code. So coffee cup full, headphones on, IDE open, let's go. And the great thing is that when we're finished, we have a working implementation. All of the effort that we're spending means that we have a working, running API. But it could have taken you quite a long time to get here. Depending on your API surface area and your dev environment, your dev loop, and things like that, we could be talking days or even weeks before you actually have a running version of your implementation. And in our 6-week project, that's a long way through our project. We don't have much room for error here. And one thing I tend to see with an implementation-first approach is that framework concerns tend to leak into our API designs. So this could be as simple as your schema looking a lot like a Java class hierarchy, because Jackson makes it really easy to serialize things that way. And this actually frustrates me a little bit. I don't like making design decisions based on what the framework dictates. I want to make the best decisions I can make for my API to make the best API I can for my consumers, not what just happens to be easy to implement in whatever framework I happen to have chosen to implement it in. OK, you've done your dev, you've got it working, time to raise a PR and get some review. And again, we know pull requests are great. We know getting lots of eyes looking on the problem increases the quality of the code that we've written and the systems that we've built. But your API is now probably spread across multiple source files. If you're working in Java, chances are you've got annotations, you maybe have some custom serializers, maybe there's some JSON or XML configuration going on. And it's really hard for your reviewers to get a picture in their head of what your API actually looks like. Best case scenario, maybe you've got some end-to-end tests that have some example requests and responses, which will let your reviewers understand your API. But the chances are pretty good that they're going to have to be looking across multiple files here to try to understand what you're trying to tell them. And this leads to what I consider to be quite low-value feedback. In my experience, you're more likely to get feedback on implementation details and style rather than the API itself. And if you think about it, implementation details, they're important for sure, but they're also really easy to change. We can refactor our code at any point. We can rewrite the whole thing if we want to. We can put it on a new language. But as soon as you have a single consumer, it becomes really hard to change your API, particularly if you're building a public-facing API. It becomes almost impossible. You end up carrying deprecation periods of potentially years. So it's really important that the feedback we get at this process is really focused on the API, not implementation details. So you've raised a PR, you've had some feedback, you've probably iterated a few times, and you've merged. Now you're in the staging environment, and it's time to actually start testing. This is great. And now we can get our consumers involved. We can get the UI team to start consuming the API. We can get the Connect app team to start using it. If we've got it in a public-facing environment, we can get our third-party vendors to start sending us some data. But how do you know you built the right thing? How do you know you didn't miss a field that you had back in that Confluence page? Or that you've marked something as optional when it should be required? Or that you've missed the cardinality of one of your array fields or something like that? It's really hard to validate that you've actually built the right thing here. And what if something's broken? What if your UI team says, hey, we actually need this other piece of information that you haven't given us? Or your third-party vendor says, actually, you've marked this field as required and we can't give it to you because we don't have that information in our system. At this point, you have to go back through your whole dev, review, deploy cycle again, and that just burns more time in our 6-week project. And keep in mind that this could be the first time your consumers have been exposed to your API, particularly if we're talking about external consumers. And if we plot this out on a timeline, it looks a little bit like this. And you can see that integration point, that point where our consumers start integrating against our API. It's quite a fair way through our project already. In this diagram, it's maybe a third of the way through our project. And in our experience, it's late-stage integrations that kill projects. There's always integration problems, no matter how carefully you plan these things. And by integrating late, you don't leave yourself a lot of time for solving these issues. Okay, so let's rewind, and let's go through this in a spec-first approach, which is the approach that my team uses at Atlassian with quite a lot of success. So when I say spec-first, what I mean here is that the API specification is the source of truth for your API, and everything else is derived from that specification. So your implementation and your consumer implementations are all derived from the API spec. And any changes that you make to your API go through the API spec first, and then are reflected in the implementation. And you can already see that the feedback loops are starting to get a little bit tighter, which is a good thing. And in this approach, this is what defines your API. It's a single, easy to understand file that's pretty concise and documents exactly what your API is doing. Much cleaner, in my opinion. All right, so let's get started. So first of all, we're going to design our API and write it out as an OpenAPI spec. So we fire up our editor and we start bashing out some JSON or some YAML. And at the end of this process, we have a usable artifact. Because we've used a formal specification, we have an artifact that we can use in our dev loop to validate our implementation, and our consumers can use it in theirs to validate their usage of our API. And it's an industry standard. This stuff has been around for a while. There's a large community. There's a lot of knowledge out there on how to use OpenAPI, how to author OpenAPI, how to implement certain API features in the spec. And this means that you can immediately leverage that community and that information. And there's a lot of tooling support. There's editors, there's pretty print viewers, there's code generators, validators. There's a whole bunch of stuff that you can immediately unlock by adopting a format like OpenAPI. Okay, so the next step I recommend is that you encode some example interactions against your API spec. These can just be handwritten just to validate that your API does what you think it's going to do. Now, you may actually choose to do this first and then derive the API spec from your examples, but the chances are you're probably just going to have a really tight feedback loop here. You're going to maybe sketch out an API, sketch out some examples, update your API, update your examples, and get this really tight feedback loop going. And the nice thing here is that if you use a format like Pact, which I'll discuss a bit later, you can actually validate that your examples match the API spec and vice versa. So any change you make to the one, you can immediately know whether you've broken the other. You get this really immediate feedback loop. And these examples form great documentation for both your reviewers when they review your API, but also your consumers when they come to actually use your API. It forms a really good set of examples on how to interact with the API, what sort of data is expected, and what sort of results you're going to give back. And these are actually usable in and of themselves. Again, if you adopt something like Pact, you can use these examples to drive contract testing, to validate that your implementation is valid, that it matches the spec that you've decided to go with. Okay, so we've got some examples, we've got a spec, time to get some review feedback. So we raise a PR. And this could have only taken a couple of hours. We could have had the meeting with our PM this morning and had a PR open after lunch. It's really measured in hours and not days. We haven't burnt much time here. And the feedback that you're going to be getting in the PR is going to be hyper-focused on the API design, not implementation details. And as I said, it's the API that's the thing that we're potentially going to have to support for years. So it's really, really valuable to get feedback on the API design at this step and not style, whether you've got a curly brace in the wrong place or something like that. And the spec is a really good vehicle to get your consumers involved. Send it out to your UI team, send it to your Connect app team, send it out to your third-party vendors. Get their feedback. Because it's an open standard, everyone will immediately know what you're trying to tell them, and if they don't, there's plenty of information that they can find out on how to understand the spec. And they can give you really, really valuable feedback on the specification that you can incorporate at this point. And your consumers can actually get started writing code right now. They can start building against your API spec before you've written a single line of code. So now it's our turn to write some code. So again, fill up the coffee cups, headphones on, let's start writing some code. And the really nice thing is that because you've chosen a formal spec format, we can validate that our implementation matches the specification. We can do that as part of our unit test, so we get this really tight feedback loop to let us know if we've broken something in our implementation. You may even choose to generate your implementation from the spec. So there's Swagger CodeGen, which will let you generate both the provider and the consumer side directly from the API spec. And you can get 80 or 90% of the way to a working implementation just by running a single command on a command line. One issue that you may run into with this approach is that you may have unwittingly made a design decision in your API that becomes difficult to implement in whatever framework it is that you've chosen to use. I actually think this is not too much of a problem. I think if you've made a decision in your API because that's the best decision for your consumers, if that just happens to be difficult to implement in whatever framework it is you're using, I just say, suck it up. You're going to have to write the code. We're engineers. We get paid to solve tricky problems. This is a problem we can solve. Having said that, if it was just a coin toss and you could have easily gone some other direction with your API that's just as useful for your consumers and makes it easier to implement, sure, go that way. Update your API spec. We've only burnt a day or two at this point. We still have enough time to make that change, get it out to our consumers, have them make changes. And if we plot this out on a timeline, it looks a little bit more like this. We have that integration point pulled way back to the start of our project. And this gives us much, much more time to address any integration problems that might arise, to fix any problems on either side of this integration. And in our experience, this leads to a greater chance of success for the project as a whole. So I'm just going to take a moment now to talk a little bit about contract testing, because I've used that term a couple of times, and I just want to make sure that everyone is familiar with what I'm talking about. So the basic idea with contract testing is that you test against the API contract of an API, not the implementation. So this is a technique that's become more and more common or more and more popular as microservice architectures have become more widely adopted, because you no longer have to set up a complicated integration test environment and do complicated integration tests. Instead, you can do point-to-point testing against API contracts and gain a lot of confidence that two services or a front end and a back end are going to be able to talk to each other successfully without having to worry about managing state and setting up complicated environments and things like that. And when I talk about contract testing, there's really two flavors. There's consumer-driven contract testing and provider-driven contract testing. On the consumer-driven side, the idea is that consumers record their expectations about what an API can provide and how it's going to behave. And then a provider validates their implementation against those expectations. So I've mentioned Pact. Pact is a really great example of a consumer-driven contract testing framework. In Pact, what you do is the consumers define their expectations as pacts, which are usually generated during the unit testing process. These pacts get uploaded to a central broker, and then the provider can download the pacts from that broker and validate their implementation. And you would use consumer-driven contract testing mostly for sort of internal development, where you've got service-to-service communication or front-end to back-end communication, where the consumer of the API is really defining what the API should do. And this is where consumer-driven testing makes a lot of sense. On the other side of the fence, we have provider-driven contract testing. And this is where you have a provider who exposes an API and a specification for that API. And then consumers validate their interactions against the API against that specification, rather than the running service or the running provider. So this is the sort of situation you find yourself in when you're consuming a public cloud provider API, for example, or when you're consuming Atlassian's API. So Atlassian has a public API. We publish a Swagger spec, and you can validate your interactions against the API using the contract testing rather than actually trying to call Atlassian APIs directly during your integration tests. Okay, so that's spec-first and contract testing. So I'm just going to run through some of the tools that you can actually use right now to implement this in your dev loops. So I'm going to go through a bunch of examples and a bunch of tooling. Don't worry too much about writing it all down. If you go to that URL, there's a blog post on the Atlassian blog which goes into a lot of detail on everything that I'm talking about and has links to a lot of the tooling that I'm going to be talking about. Okay. When it comes to actually creating your spec, there's a few options. There are a bunch of plugins for text editors and IDEs and things like that out there. VS Code, IntelliJ, Eclipse, things like that. And these will give you syntax highlighting, code completion, schema validation, all of that nice stuff. If you want something a bit more purpose-built, there's the Swagger editor, which is a web-based editor that gives you a nice side-by-side WYSIWYG editing for your OpenAPI or Swagger spec. When you come to encoding your examples, I recommend checking out Pact. It's a contract testing framework, but it actually has a really nice format for specifying request-response interactions. It's quite concise, easy to use, easy to encode. And the nice thing is that if you adopt Pact, then you immediately get to unlock the use of Atlassian contract testing CLI and things like that to validate your examples against the specification, which is really nice. If you decide to generate your code, check out Swagger CodeGen. This is a library or a tool set that's put out by the Swagger community and includes a lot of community contributed generators for both the provider and the consumer side in a range of tech stacks and frameworks and tooling and things like that. And it's really highly customizable. So you can actually define templates to generate code in the style that matches your team or using libraries that your team is using and things like that. We have teams at Atlassian that are using Swagger CodeGen to generate scaffold implementations on the provider side. We run on the JVM, so we're generating Kotlin implementations, and we then implement those interfaces. Anytime we make a change to the spec, they get regenerated, and we get a compiler telling us if we've broken something or if we're missing a method or something like that. So really quite useful. You can get a long way to a working implementation directly from the spec. When you come to validate your implementation, which is really closing that loop on the feedback loop, there's a couple of options. There's the Atlassian contract testing CLI, which is a language-agnostic CLI tool that was written at Atlassian. It's mainly aimed at performing contract testing, but it has some functionality which will let you validate that your mock data matches your API specification. And this is really useful for both the provider and the consumer side. If you're running on the JVM, I recommend that you check out the Swagger Request Validator. This is a Java library that has support for validating request-response interactions and has drop-in modules for Pact, WireMock, Rest Assured, Spring MVC, things like that. I'm actually a little bit biased on this one. I wrote and maintained that library, so I think it's pretty cool. If you're interested in learning more, come and find me. I'm more than happy to chat about it. Okay, so that's the tooling. So let's just wrap up and see where we've landed. So remember, your API is the thing that you're going to have to support for a long time, not your implementation. And with a spec-first approach, your API spec is the central component of your development lifecycle. It's the first-class citizen in your development effort, which really helps put the focus on your API and not on the implementation. And if you adopt a spec-first approach, you immediately unlock a number of really nice benefits. You get a tight feedback loop that's measured in hours and not days. You get effective feedback. All of the feedback that you receive is going to be hyper-focused on the API design and how it behaves and its style and its consistency, not on implementation details. You get minimal wasted effort. Every artifact that you've produced in your dev loop is usable. You haven't built text documents that are going to get out of date. And you haven't invested a lot of time in building an implementation that you're then going to have to go back and change as soon as you find out that it doesn't meet your consumer requirements or something like that. And you also unlock contract testing almost for free. A lot of the tooling that we're using comes out of the contract testing kind of world. So you immediately get to unlock contract testing to validate that your implementation matches the spec, and the consumers can validate that their usages also match the spec. So that's it. So think API first and do spec first. And apparently I have a lot of time for questions. So any questions?